Welcome to Introduction to Database Systems. In this first segment, we'll go over course plans to give you the big picture. Be sure also, though, to read the course guide and the online structure documents that are provided on the course site. There are a lot of important details in there that we won't get into in this overview. Now, the course is designed to give you several things. First, a working professional's knowledge of SQL. A large majority of software work involves interacting with databases. SQL, or Standard Query Language, is historically the language of choice for this, and it remains important even with the recent growth of NoSQL databases in big data applications. It also has been the language of choice for an amazing 4 decades, making it the longest-lasting present-day software technology in common use except for C. SQL, as we'll see, is not a full programming language, but it covers just about anything you'd want to do with a database. It's not just good resume material, it's really must-have material for professional use. Now, the second goal of the class is to give you an ability to design databases for efficiency and maintainability. You'll surely use databases as a software professional, but you're also likely to design them. Database design is an art like any other kind of software design, and we'll do just the basics in this course. For issues like database normalization, see a follow-on course. But we'll have at least one practical exercise asking you to take a large, unstructured body of data and organize a database for it. The third goal of the class is to give you an ability to interact with databases from programs, for instance, via JDBC. In the course, we'll do a lot of SQL work via command line tools that perform textual SQL on a database. Some database work via command line SQL is done in practice, too, but like any command line tool, SQL is not for the non-technical. You'll see command line SQL in development environments or when a serious expert is performing under the hood work on a functioning database. But the large majority of database interactions is done by programs. For instance, websites or GUI tools that present a user-friendly interface and perform database operations on behalf of the user. Now, does this mean that for all my talk about SQL's importance, it's really just a geek tool? No, the programs also use SQL. So if you're going to write any code that interacts with a database, you first have to understand command line SQL. But it takes some additional knowledge and appropriate libraries to generate the SQL automatically from a program. We'll do a small project requiring this later in the course. Now, a fourth goal of the class is to give you familiarity with database theory, in particular relational algebra. The class presents practical database concepts and projects first, in keeping with the philosophy that it's easier to understand an abstraction when you have something concrete to pin it to. But that doesn't mean we'll ignore the interesting and important mathematical theory and notation that is at the heart of modern database design, relational algebra. You can think of relational algebra as a generalized form of SQL expressed mathematically, but any serious theoretician would box my ears for even saying that. They insist that it is SQL that is merely one implementation of relational algebra. Philosophical debates aside, the practical fact is that sophisticated work in database, especially optimizing database queries, requires a clean abstraction and associated notation, and that's relational algebra. Notation and abstraction matter. Using SQL instead of relational algebra to discuss query optimization is like using Roman numerals instead of base 10 values to do long division.